Welcome to CO2 Mondays with Trevor. I'm super excited about this. I really decided to start this because of the morning coffees with Trevor. I had a lot of value out of that. I did 34 days straight of just talking about refrigeration. And what came of it was a lot of people want to learn more about CO2 refrigeration. And I'm very passionate about refrigeration, and I'm really passionate about CO2 because I've been training for many, many years, but I see where it's going and the future of CO2 in commercial refrigeration. And I don't believe the industry and the technicians, even the designers and engineers, are ready for the amount of CO2 projects that are going to be out there and the knowledge that's out there. And I really want to try to give back. And this is why over the next 12 weeks, I'm going to be talking about different topics on CO2, technical topics, design topics. I'm going to invite quite a few of my friends on to talk about CO2, experts in the field, people who have designed systems, technicians who have installed hundreds and hundreds of CO2 systems, and we're gonna just chat it out. And you guys are welcome to put stuff into the chat box. You can unmute yourself and ask me questions. A little bit about my story and journey in CO2. The first CO2 system that I've ever seen was probably back in 2013, and it was a secondary system. And really what that is that you have a refrigerant on your primary side, and then your secondary side would be CO2 as a liquid, and that would be using a pump that you would pump out to coils and cases. And that's my first experience with CO2. And I didn't really think much about it because I was doing service at the time. I didn't do the install or anything, but I was introduced to it at that point. A few years later, because after that I just went back into doing mostly synthetic refrigerant supermarket work because that is my background. But a few years later I started with a company called Emerson Copeland, and I worked there for 7 years before now starting Refrigeration Mentor. But during my time at Emerson, I've learned so much about CO2 as a refrigerant, and I had the opportunity to be one of the lead trainers for North America. So going around Canada and the US doing CO2 trainings for technicians. And I've trained thousands of technicians, both in person and virtually, on CO2 refrigeration. So I've learned a lot over the years. And what it always came back to is that there's, I think, a little bit of a fear factor that people have about CO2 as a refrigerant. And the reason is that they have not been introduced to it, and they haven't had someone talk to them about it. And most technicians that I've trained, and after the training, they're like, wow, that's just another refrigerant. Because it is. It is another refrigerant. And it's important to really understand that. There's been a huge cycle of refrigerants over the last 100 years. And a lot of people think CO2 is a new refrigerant, but it's not. We were using, or people were using, a CO2 as a refrigerant over 100 years ago. But in the mid 1900s, synthetic refrigerants came out, and over the years that has been used. But we're now back into the cycle where we need to use more naturals, because the cycles of, okay, we went up until 1987, and we had the synthetics that were, ozone depleting, because they found that out and they figured out there was an issue with those synthetic refrigerant causing damage to the planet. So then they phased them down, phased them out, whatever you want to call them. So they removed them from the list used. Then we got into the HFC phase, and we used those for 20 or 30 years. I'm not sure the exact. Some of you may know the numbers exactly. Now we're in a phase where we're using, phasing down and phasing out other refrigerants because of global warming potentials. So anything that has high global warming, you can't use them in certain countries around the world, depending on where you're at and listening today. And I really believe that over time, it's going to happen again. Even with these new global warming, low global warming refrigerants, they're so new, we don't know what the next thing is for them. And I really believe CO2 is going to be one of the main commercial refrigeration refrigerants that's out there. Over my experience, over the last, say, 7, 8 years with CO2, it has grown immensely. And some of you may have seen this in your countries as well, but each year, if you ever follow Sheco or Atmosphere Now, great resource on natural refrigerants, but year over year, you would see numbers doubling, up 20%, up 30%, up 50% on the amount of CO2 systems globally. And it's not only in commercial refrigeration, you'll see heat pumps with them. And you're going to see more and more commercial heat pumps. You see chillers now with CO2 in them. Lots of supermarket applications, condensing units, little pop coolers with CO2. I've seen one actually a long time ago, and I was driving to going to Eastern Canada, and I stopped at a gas station where there's like convenience stores, and there was actually a Coca-Cola machine there that said R744 on that. I'm like, that's interesting. So there's a lot of applications with CO2 as a refrigerant. And really my goal over the next 12 weeks is introduce some maybe new terms. You may know these terms. I'm going to have, like I said, some experts come on and we can ask them questions, because I'm really here to learn myself. Even though I've trained it for years and years, I have a lot to learn about CO2 refrigeration. And I have a lot of great mentors in the industry for CO2. I spent many years with a great gentleman named Elaine Mongrain and Andre Patnaud. And these guys know CO2 inside and out. And we had many great conversations about the trends of CO2 and where CO2 is going to go. And I continue to see it and continue to watch it grow. And now that I meet more and more people outside of, inside the refrigeration industry, but outside of my circle, so I'm meeting more and more people. A good friend of mine, Kevin Cumbus from Advanced Refrigeration Podcast, he says he has done over 120 CO2 installs. So that's a lot of installs, and that's just one technician. And this is happening constantly that we don't even know about. Like I didn't know like that he has done that. I knew he did a lot, but he said over 120. So I'm learning so much from him. I also have great friends that are manufacturers. I don't know if you guys ever heard of Advancer, but Lars Jensen, I've sat in on his trainings. I continue to invest in myself to try to learn to be better so I can educate you and educate the industry, because I know it's here already, CO2, but we're not ready. The technicians aren't ready. 90% of the technicians I talk to, even in commercial refrigeration, they say, I didn't even know we had any stores with CO2 refrigeration, transcritical stores. You're going to hear these words, transcritical, subcritical, and it's important to understand that, because I have lots of good friends that called me up over the years. I remember a couple of years ago when I was doing some trainings when I worked at Emerson, and they're like, hey, Trevor, how you doing? I was on call last night and I had a rack that was down and it was a CO2 transcritical store. I didn't even know we had CO2 transcritical stores. And so this is where communication is very, very important in the commercial refrigeration industry now. Because for me, as a technician on a service call, if I go up to a brand new store that I've never been at, and then all of a sudden I start seeing things look different. I got stainless steel pipe all of a sudden. I got different vessels that look a little bit different than your standard receiver, right? Because we'll get into flash tank and what that does. But it's really important that we all start to talk about this more, and more of a community of CO2 refrigeration, so people aren't scared. And that's one of the big things that I want to help with, is that take the fear of the CO2, but you need to work on this equipment safely, because there are differences. And it doesn't matter, synthetic refrigerants, there's dangers to that, and there's dangers to natural refrigerants. There's dangers to anything you do in a skilled trade, because that's what refrigeration is a skilled trade. And every day we're working with electrical, we're working with chemicals, we're working with a lot of different things. So it's so important that we are out there doing our role safely. And with CO2, you just need to understand the differences, things that you can do and you shouldn't do. What I've found, and I've noticed from training thousands of technicians, is that synthetic refrigerants let technicians get away with a lot. Now with CO2, you need to do it correctly. And I've seen this because when I worked at the manufacturer, I could tell is when a system wasn't installed properly. It's easy to tell that because you get compressors that come back or components that come back and they're all copper plating. Now, if you have copper plating inside of a compressor, well, that's due to that installation. 99.9% of the time, it's because of the installation. There's other things on service side that could cause that copper plating, but this is where you're getting moisture in your system. And with CO2, there's no cutting corners. With natural refrigerants, you shouldn't be cutting any corners. And it's important to understand that. You need to do the job right. And I believe that there's so many years that we just got away with a lot as technicians in the field. Because I've even did it. Don't get me wrong. I've done those quick evacuations. I didn't even know what a micron gauge was for a lot of the first years in the thing. It was like, oh, it's green, it's good. If it's hit the green, it's good. But that's not it. You know what I mean? You need to have that micron gauge on there. And so with CO2, some of the safety things is that we're going to deal with higher pressures. There's higher pressures in the system. So you have to be aware of that. My experience on troubleshooting CO2 systems is that I believe they're a bit easier because now I have a lot of electronics. Everything is done electronically. So I have a controller that I can read all the temperatures and pressures of the system. And so instead of going up and being very afraid of it, it'd be like, wow, this is an opportunity to learn a bit quicker. I can see all the different parts of the system. I spend a lot of time with a gentleman named Pierre Levesque. He's a manufacturer out of Quebec, and he designs lots of industrial CO2 systems. And he designed the trainer that I was using when I worked at Emerson. And I spend a lot of time learning from him because he's an engineer, he's a technician, he's a super smart guy. So I was able to spend time and really understand the concept of CO2. And when you look at pressure enthalpy chart with CO2, I highly recommend doing that. I may do that over one of the weeks. I'll bring one up and we'll talk about it and we'll talk it through. But when we were sitting there, he was just talking about how it works inside the system and the pressures and the mass flow and the way the characteristics, the way that CO2 works with the oil and how it's miscible, and understanding these little nuances where in CO2, synthetic refrigerants, the manufacturers say, okay, well, we always like to see like a 15 or 20 degree Fahrenheit superheat back at the compressor. We'll say 6K if you're in SI units. But it's important to understand that in CO2, they do not mix the same way. That oil, that POE oil, does not mix the same way. And so now you have to have a higher superheat. These are things that you just need to understand. I've seen many, many compressors when I worked at Copeland come back because superheats were not maintained. And I believe I talked to other manufacturers. So I talked to Advancer, I've talked to Hill, I've talked to guys from Hussmann, I talked to lots of technicians out there. And one of the highest cause of failures for CO2 compressors are from floodback because not maintaining that superheat. So this is something that a lot of technicians don't really even check as well. I've done lots of trainings. I've inspected hundreds and hundreds of compressors, dozens of CO2 compressors, and I've seen that either we're not following what manufacturers say, like Copeland, like Bitzer, like Dorian, like Bach, whoever the compressors you're working on, we're not following that a lot of the times. Yes, things happen in the field, maybe a valve fail or fans get stuck on or you have really low loads not set up properly. But a lot of the times it's the way the systems were set up. And with CO2, these are the things that you need to understand. Higher pressures, to me, now that I've worked on a lot, is not the scary part of CO2. It's really helping the other technicians understand that you just need to watch out for things. Like you do not want to trap CO2 because it has a huge increase in pressure with temperature. Where in synthetic refrigerant, you could just shut shut and trap, say, 404A gas, that if it's not heated, then the pressure's not going to build. If you take a torch now and you trap that 404 or 134A and you just start heating it up, all refrigerants are going to build in pressure because of heat. You increase pressure, you increase temperature. It just CO2 just will increase at a massive rate. I think it's for every 1 Celsius, it's 10 bar maybe, or 145 PSI, give or take. And maybe you guys can throw in the chat there what it is. Some of you probably know what it is, but it's important to understand that. And when I first started learning about this, I was taken back by some of the stuff because it's so new. But if you want to become very good at commercial refrigeration, especially in the CO2, you need to start doing more research. You need to go to the Advancers, the Hussmans, the Hills, the Septex, the System LMPs, the M&M Refrigeration, the Carnot, I think they're the same now, Simco. There's so many manufacturers that's mostly here in North America that I know. There's some that I'm starting to learn more and more. I'm starting to build relationships with more European ones. But as technicians, as engineers and designers, you need to start building these relationships. They may be a competitive brand, but as an industry, we have to work together to make our trade safe. We do not have enough people in our industry. One of the things I've been working on for heavily over the last 6 months, and definitely the last few years, is getting more people into refrigeration. More people, more technicians, more salespeople, more project managers, just to enjoy a great career, because refrigeration is amazing. And this is why I really love CO2, because it's really new to me. Very passionate about refrigeration. And this is an opportunity for me to share more knowledge that may be a little more advanced, than maybe learning supermarket refrigeration or condensing unit refrigeration. But refrigeration is still refrigeration. I train lots of different people that work on, say, residential unit, light commercial, HVAC units. But at the end of the day, refrigeration is refrigeration. You have some more components in certain systems or applications. You may have more refrigerant, but at the end of the day, it's the same thing. You need to increase the pressure, you need to reduce the pressure to increase the temperature or reduce the temperature. So we can, absorb heat and reject heat. And it doesn't matter if it's a high temp application or an ultra low temp application. Refrigeration is refrigeration. And when you start to wrap your head around that, it makes it a bit easier. I know there's a lot of people that I've worked with that have been, like I talked about, very fearful of working on CO2 systems. One thing that you want to understand is that you don't have to just go and throw gauges on. Like I said earlier, there is a lot of pressure and temperature transducers on systems. One thing you really need to understand is the control system. That's where a lot of people are also fearful, because they don't understand the controls as much. But I'll tell you right now, as a refrigeration mechanic, refrigeration technicians, you need to start learning controls. And if you're a designer or an engineer on here, you need to understand the controls you're putting in your system, because everything is controlled in a CO2 system. You have electronic valves. You do not use mechanical valves like TX valves in a CO2 transcritical system. You'll be using electronic expansion valve. So that is something you will need to learn. And it doesn't matter if it's in CO2 or if it's in a synthetic refrigerant, you need to learn electronic valves. And they're going to continue to grow popularity. Over the I've been working with electronic valves for 7 or 8 years, but they've been out for 20 or 30 years, electronic valves, maybe even longer. But as technology advances, prices reduce, and we're going to see more and more and more electronics in systems and more controls. And that's what CO2 systems are. It's all controls. And it's important as a technician to spend the time to invest in yourself and learn that. Learn the different types of controls. And it doesn't matter whose controls it is, you need to take the time to understand it. And this is what I see in a lot of the trainings I do now. that when I talk to technicians, they're like, I'm not super comfortable with the controls. I can get by with the controls, but I don't know the service side of the controls enough, or I don't know the installation or programming of the control enough, depending on what your role is. Do you need to be an expert at programming that facility manager controller? No, you do not. If you're a service technician, you need to understand all the service side of it. How do I get in and change a point if something happens? Where do I check the different temperatures? How do I know if it's in transcritical or subcritical? What's the difference? Right? And that all depends on the temperature. Every refrigerant has a critical point. It's just CO2, you hit it in our, in our summer days. And depending on where you're at in the world, you may be there almost every day. It's where CO2 right now is really good in colder climates. But over the last, I say, 5 or 6 years that I've been working, training, dealing with CO2, you're seeing them everywhere. You can see them in the warmest climates in the world because of warm ambient strategies. And really why we didn't have them in the warmer climates, because it just costs a lot of energy. It uses a lot of energy because in a basic booster system, you're bypassing 30, 40, 50% of the capacity. And with these low ambient strategies, you don't have to waste as much of your capacity. You guys feel free to throw some questions in the chat if you want. If you have any questions, I'll do my best to answer because, like I said, I'm still learning a lot of stuff myself. So one of the big things is to understand the difference between when you're in subcritical and when you're in transcritical. And really there's one point, and the point is the transcritical point, or they call this the critical point, is at 87.8 degrees or 31 degrees Celsius. You could say 88, it's even, anywhere's around there. That is where the critical point of CO2 is. So when you're above that temperature, you're in a supercritical state. So that's why they call it transcritical state. But there are a lot of manufacturers that will, even in the wintertime, put their system in transcritical mode. Does anybody know why? Why would I, in the middle of the winter, put the system into the transcritical mode? I'll let you guys throw it into the chat. But they do that, and there's a reason for doing that. But when you're in that transcritical mode, David Campbell, heat recovery, 100%, David, thank you. But when you're in there, there's no temperature or pressure relationship. So this is where you need to think about inside the pipe. Inside what's happening actually inside the system at that point. Because for me, when I think about a condenser, well, they're not called condensers anymore. They're called gas cooler condenser. But when I'm thinking, well, that looks like the condenser, but we're above 87.8 or 31 Celsius, it's not condensing anymore. All you're doing is dropping or lowering the temperature as much as possible. So that's the big difference. That's why it's called a gas cooler. You're trying to cool the gas when you're in that transcritical mode. And you're not condensing. Adam put heating, yes. Yeah, so yes, what about CO2 systems in a hot temperature zone? Yes, they're all over the world now. You'll see them. I have a good friend who's been on a lot of my morning coffees with Trevor, and he's in South Africa, and he says he's been doing CO2 refrigeration for, I believe, over 11 years. I can't, is it 8 or 11 years? Oh, so 2011. So it's over, yeah, so 11 years. And he says, Trevor, we have days that it gets up to 42 Celsius and does not have a problem with the CO2 system. No issues whatsoever at those temperatures. So if we can run CO2 systems there should be no problem anywhere else in the world. And he's been working with CO2 for years and years and years. And he sees the same, told me he sees the same thing. A lot of people are afraid of CO2 because of the pressures. But if you understand the safety of it and understand how to be safe working with it, it's a very fun system to work on because it's definitely different. For me, I loved it because I spent 10 years in the field working on supermarket, working on chillers, working on um, air conditioning, commercial air conditioning equipment. But now I have something that has advanced technology on it. It has VFDs or digital compressor, electronic valves, ECM fan motors, whatever it is, all these different specialty valves. You get a high pressure valve and you get a bypass valve that we'll get into over the weeks. But it's so important to, take this time to understand what each component does. And it doesn't matter what system really it is. It doesn't matter. Even a standard system out there right now, you should be taking the time to understand each component. I'm doing trainings right now with multiple contractors all over the world. And that's one of the things I ask the technician. It doesn't matter if the technician's 2 years in or the technician's 20 years in. Sometimes they don't understand that specific component, maybe if it's new or they forgot it along the way. But the experienced guys that spend the time to learn it, I can see the difference. And even the newer technician, 5 or 6 or 7 years in, the guys and the technicians or girls that spend the time to understand exactly what that component does excels way faster. And this is the hard things about refrigeration, air conditioning. A lot of times when something's hard, you don't want to do it. But I challenge all of you right now, if you're in CO2, if you're working with CO2, or you want to start working with CO2, you can reach out to me. I can send you different trainings that are free out there. I do paid trainings as well as free stuff like this, but I will help you get that understanding. There's lots of free resources online. You can go up and write Danfoss. You can go write Emerson. You can write Bitzer. You can write whoever and write CO2 at the end, and stuff's going to pop out because all these manufacturers are making and planning equipment for CO2 industry, CO2 refrigeration. That's already out there. And there's lots of other manufacturers that we'll talk about over the next few weeks. But it's important that you, as a technician, as a designer, as an engineer, doesn't matter what your role is, if it's construction or service, you need to understand first the basics, then the components, how they work in conjunction with each other, and then what it should look like after they're running properly. Because I think that's one of the things a lot of service technicians, as I was a service technician for a long time, I would get out and I would always see when a system's like on fire, there's massive issues and nothing's working and nothing running. But you need to take the time on these new systems that are running and working properly and understand what is going on and ask the question why. That is the big thing, why. Because even a lot of these systems, and I've talked to a lot of technicians, they're like, well, I got this equipment from this manufacturer and there's issues with it. And so the manufacturer comes out multiple times and then they find out what it is, what the problem is. And sometimes I know there's systems out there right now, I've talked to guys, they can't figure out what the issue is. And the manufacturer cannot figure out what that issue is with that system. Because it's still it's a new technology, but a very old refrigerant. Right? I think we got back into CO2 in the late 80s, early 90s. That's when CO2 started to come back, and it's really started to grow probably early 2000s. I think that's when it came to late 99, early 2000 came to Canada, North America, in through Quebec. And that's why there's a ton of manufacturers in Quebec that design CO2 systems. Who do we have? We have, Septec, LMP, Carnot, which is M&M, Zero C, Arneg, and that's just a few I can think off the top of my head. There is many more. And you need to start contacting some of these if you're working on that equipment, and you call them up and ask them the question, why does this do this? Because if you're not asking the why, you're not curious enough on how the system works. And that's why I feel like I'm continuing to learn about CO2, because I'm asking the why, because there's so many different things that I don't understand. There's multiple oil management system designs that I've seen. I don't know if how many of you worked on a CO2 system, but I've seen multiple designs on oil system, the oil management system, having one separator or two separators or one separator for two compressors on the same medium temp or transcritical system. Different designs. And it's important to understand why they're doing it that way. It's so important. Why do I have 6 oil separators on this one rack? And it's a massive rack, 12 or 15 compressors, but why? And these are the questions you want to ask, because you should understand that, especially if you're servicing it. And if you're installing it, why? If you're in construction, there's so much to learn. I love construction. I highly recommend, if you're a service technician, you get an opportunity to do some supermarket construction or commercial refrigeration construction work. It opens up your eyes. It made me a way better service technician to understand the construction side. Because I've done a lot of things in the construction that pissed a lot of service technicians off because I didn't know I was doing it wrong. And then when I thought about it, well, I put that valve way back there, or I put it up in the ceiling where I needed a 14-foot ladder or a skyjack to get to it. So you learn these things over the year, but I highly recommend, if you have that opportunity to learn that or see it, it gives you a better perspective as a service technician. And then no different with learning CO2 as a refrigeration. Okay, good question here from Adam. We also push up to transcritical early. I've been told it's because the high end of subcooling is the least efficient. Do you have any input on that? The high end of subcooling is least efficient. I'd have to look into that. So one way, there are in different controllers, I know that both the iPro, that's Dixel, the Danfoss, the microthermal controllers, those ones that I know, they'll have like good, best, and better scenarios inside their algorithms. So depending on where you're at on the heat chart of the enthalpy diagram, you may want to push it up higher to hit this certain heat line to get more efficiency out of that system. So I've definitely heard of pushing the pressure up to get more efficiency out of a system before. But this is a good question that I will ask some of our friends that are going to come on over the next 12 weeks and ask them these questions. But yes, there's certain times when you want to push the pressure up higher to be more efficient, the system to be more efficient. But I don't know the exact answer right now on that, Adam. I should, to be honest with you, because I've said it many times before, drawing a blank. But as a service technician, you want to be aware of those things. Like a lot of the time, I've seen it when I've worked with technicians doing trainings where they're like, Trevor, I just shut off the disconnects of the medium temp side. And then all of a sudden, I heard the relief valve go, and then there was no gas in the system because that low temp is pumping into the medium temp. So if that medium temp is not running, then you're going to run into that issue. So understanding you need to have that medium temp system running so the low temp system can function. So transcritical is the medium temp, low temp is called subcritical because you're below that critical point, and that's why we call it subcritical. And just there's a lot of new terms that you will learn when you're dealing with CO2. There's a lot of terms you're going to hear: gas cooler condenser, you're going to hear transcritical, subcritical, you may hear supercritical, you're going to hear like high pressure valve or magic valve or HPV valve. You're going to hear about the bypass valve, a flash gas bypass valve, receiver bypass valve, some people call it. So these different names and terminology you want to understand. You're going to have depressurization valves in certain oil management system ones. And you're going to see more and more of these, and you want to understand these terms and where they're at in the system. Like, why is that valve, why does it do that? You know, the oil management, even on regular systems, electrical and oil is probably the hardest things for people to understand and learn. And now when you're dealing, say, with a single oil management system for both transcritical and subcritical, you have to have special devices inside there. And when I worked with Pierre Levesque from Septec, and when he designed the oil management system for the trainer for Emerson, when I was doing the training for them, it really blew my mind, because now you think about it, your transcritical side could be running at 1400 psi sometimes, and people are like, oh my god, 1400 psi. Yes, when you first hear that, it's kind of shocking, but after you work on it, okay, 1400 psi, well, what's the temperature outside? Is it Is it above 87.8 or 31 Celsius? Yeah, we're warm. So, okay, our pressure is going to be higher. And you're going to see this on your, either on the gauges on the system or on your controller. But when I seen it, I'm like, you have one oil management system, you have your transcritical and your subcritical going into your separators. So you get like a high pressure separator and a lower pressure separator, and they go into the same reservoir. And you're like, well, what happens when, that low temp subcritical compressor needs some oil? Is it blowing 1400 psi of oil into that compressor? Because what would happen? That would just blow all the oil right out. But he designed it in a way where there's valves that'll open up and you'll depressurize certain areas, and you won't be blowing that amount of gas inside that low pressure compressor or that subcritical compressor. And it's really cool to see these different designs so you understand that, because that's the thing. It's being curious about CO2. And there's many different oil designs. Adam, 1400 psi is fine as long as it's still in the pipe. 100%, Adam. 100%, as long as it's still in the pipe, because it's loud. I've definitely let reliefs go. I cause them to blow, and that's what you learn about that. But you want to be safe, and you want to understand where's it going to blow if it's going to happen. Because one great thing about CO2, there's safety reliefs everywhere. The only time you want to be aware, depending on who designs the system, there's a lot of systems out there where they're designing with check valves around any place where you could trap refrigerant. I said earlier, you never want to trap CO2 because that pressure will increase dramatically. And there is copper out there now that is going to be able to handle that pressure, like K65, I think it is, and then XP65, depending on the brand. So they can go up to 120 bar, 135 bar. I can't remember all the exact numbers. But we're going to get to a point where you can just shut down a system and you're not going to have to worry about anything releasing. They're building units like that, and that's one of the big things that I've heard over the years that customers want. I want to be able, if I lose power in my building, that everything's going to be able to stay in there. But there's so many things that you can do safety-wise to protect that, like auxiliary systems to keep it cold. As long as you can keep the refrigerant cool in an area, you're not going to blow reliefs. But more and more components as well are becoming rated for the high pressure. And we're going to see that continually to happen. And that's why I'm going to do in these next 12 weeks is to share some information. If you have questions over the next 7 days, shoot me an email, bring them to the next week's session, because I want to try to answer all the questions that you have. I won't have all the answers, I'll tell you right now, but I will bring people on that will have the answers, or I will find the answers out for you, because I think it's important for you to know. And those of you that are more curious, you're going to learn quicker and you're going to find the answers yourself, because it's out there. The answers are out there. I did trainings with Emerson. I've done trainings with Bitzer, Danfoss, Advancer. I did some Hill Phoenix trainings, and I'm still learning. I'm just starting to learn about CO2. Even though I've been spending 7 years and even training thousands of technicians, I'm just learning. And I want to try to help you understand it as well. Next week, I'm going to have my good friend James Bailey on here. He's been working with CO2 for a long time, and he's an engineer out of the UK. And he's going to talk kind of about the engineering side of CO2 and hopefully bring a perspective that maybe you guys will have some questions on it. Because I really think as a technician, for me anyway, I started to get so much better as a service technician when I started to learn the design and the engineering side of it. Why are the pipes sized like that? What is the velocity in there? What does mass flow mean? What does the density of that refrigerant really mean? And why does it do what it does? Being curious like that as a technician is going to make you a better technician. And same with the engineers. The best engineers that I know could go out and service the systems. They can go out and, fix the system out in the field. And I know lots of them that were technicians in the field that became engineers, or they were engineers, they became a technician, and now they're running and working at some of the largest manufacturers in the world. But they understand the whole dynamics of it. And that's when you start to excel as a technician or an engineer, is when you understand all the sides. And over the last 5 or 6 years, I've been trying to learn as much as possible on the design side of CO2 to really help me understand it. Well, why do I have to use stainless steel as the header on the gas cooler, but all the pipes going through are copper? Does anybody know? You can shoot it in the chat if you do. But that's the thing. It's like I was curious in finding that out, because you can get gas coolers that have stainless steel tubes through all of it, but most of them are not. They're copper. And these are the things that I always wanted to ask and find out. And what gas do you use while you're purging through the stainless steel? And I actually only found this out recently through one of my trainings that I was on. And these are the things that you want to know. And I think it's argon. I think that's what the guy told me. And I'll have to double check that in my notes. But you need to understand this. And because lots of people, well, why do I see a stainless steel header there? Well, it's because of the pressures. And when you get a larger diameter, say copper, the walls are thinner. So it only can handle so much pressure. That's why they came out with the copper with some iron in it. So that K65 or that XP, I believe it's XP65. I'll have to double check those names. It should be a bit more accurate on that, but Mueller sells it for sure. And all you have to do is go in Google and write copper rated for CO2 refrigeration or high pressure copper, and you'll find it'll come up. But be curious about that, and you'll look at it. I seen it. I was down at the UA in Ann Arbor doing some training there a few years ago when I worked at Emerson, and they had the two different copper, and I looked at it. They had the standard K, and they had this K, I believe it was K65 at the time, and you could tell, you can even see it with the same size pipe, but it was a lot thicker. And then you'll notice lots of different things as well, is that the CO2 lines are way smaller than standard refrigerants, synthetic refrigerants, because it's pulling more net refrigeration effect through those lines. It was the first, when I worked at that first CO2 store that I did, that secondary system store, it was kind of funny, is because the suction and the liquid line were the same size. They were both 5'8". I'm like, what is this? Why is the liquid line and the suction line the exact same? And that really got me. That's when I was starting to get curious about it. And then I asked questions. But you'll see that. I've seen multiple lines being mixed up because they were the same size. So it's interesting, all these different things that you can learn, and you want to start developing yourself. You need to, if you're in commercial refrigeration, you're going to start seeing CO2. More and more manufacturers are making condensing units that are CO2, transcritical rated. More manufacturers, you're going to see, if you go to any one of the big manufacturers here in North America, Kaiser Warrant, Hill Phoenix, Hussmann, you're going to see you'll go to their website, they'll have CO2 information on their equipment. Maybe not all the information that you need, but everyone's getting to CO2 in commercial refrigeration. You're seeing this more and more. I've seen it over the years. I've seen manufacturers that weren't doing anything with CO2, now they're into CO2. And this is within 5 years. And you're going to see more and more of this. So start preparing yes, K65. So start planning now, invest in yourself, start learning more about CO2 refrigeration. There's tons of great podcasts out there. And, my good friends at Advanced Refrigeration did a few of them. My good friend, Brian Orr, had a few people on talking about CO2 as a refrigerant, like Rusty Walker, Don Gillis, I think a few other people as well. So he had Kevin Compass on as well for CO2. So invest in yourself and start learning more about CO2. Like I said, this is just a start for the CO2 Mondays, our Monday with Trevor. So I would love to take any questions now for the next 15 minutes. And if we don't have any questions, then think of those questions for next week. I'll have my good friend James Bailey on to talk about CO2 refrigeration. And definitely let me know things that actually just shoot in the chat box. So everyone right now, open up your chat and write in, um, are you new to CO2? You're intermediate, or you got some knowledge? So write just some, new, some, or advanced, or a lot. Write that in the chat right now. So I kind of want to see kind of where we're at with the group here. Some, new, some. Awesome. Intermediate, new. Okay, great. So we got a good range. So so Chris, so you say you have intermediate, and I'm just randomly picking. What have you worked on some equipment? Are you a service tech? Are you an engineer? I'd love to hear a little bit about your experience, Chris.
Okay, well, I'm a service tech, and
Hey, Chris.
I've had a few years of experience with CO2 maps. Not a lot, but I'm a service tech now for close to 25 years, and been working in refrigeration for a while.
Awesome.
So,
Awesome. Yeah, it was a bit hard to hear you, Chris, there, but yeah. So you worked on it a little bit. Have you ever charged a system then? Have you ever charged gas? CO2 to a system?
yes. Not a transcritical rack, but a subcritical rack. Charge.
Okay, great. So you have some experience, which is good. So you worked on it. You added some gas to a system. So that's step one. Understanding
Worked on
that.
several transcritical racks, but never one charge transcritical rack.
Okay, thank you. Anybody else want to share their experience with CO2 if they have any? Adam, you started 2 SCM racks. So SCM, I'm starting to learn about them. So I've heard about them a few years ago, but I only started investing time in trying to find some more information. On their website, they do a bunch of 2-day trainings at their facility. I think when I can, I'm gonna go out there and do some training with them. I can't really find any documents on their stuff though. Like when I go onto their website, Adam, I see you shaking your head, yeah. Where do you find their manuals? Like when I go to other manufacturers, like Bitzer Australia has lots of their manuals on their racks because Bitzer builds CO2 racks in Australia, and they got lots of great detail. I learned so much from those ones. So you can shoot it in the chat there. Anybody else want to share some of their experience? Comes with the pack usually. Yeah, I'm going to reach out to them and try to see if I can get some of their material, like their manuals, their actual manuals, because I want to get a better understanding of these different rack manufacturers. So I get a better understanding on how everybody does it, because there are different ways of the design and how they work. Some will have parallel compression that we'll get into. Some are just basic booster packs. Some will have ejectors on it. Some won't have ejectors. Some will be flooded systems. So it's learning all these different things, and we'll get over the week. One of the things that I want to talk about with new people, one thing that I haven't mentioned yet, and we'll talk about it over the weeks, is that you need to charge vapor first. Where when we talked about it for years and years now, with glide refrigerants, you need to charge liquid. You need to charge liquid into that system. But now when we talk about CO2, when we're below like 61 psi, we're below, it's called the triple point. When we're below that triple point and you try to charge, say, with liquid, you're going to get something called dry ice. And that's something to be aware of. But I've talked to so many technicians that installed hundreds of applications. They say they never seen dry ice or never caused dry ice in the system. There's a few times when they were taking like changing the liquid line filter dryer where there was a little bit of dry ice in there. But besides that, inside the system, they never came across an issue where they caused dry ice in the system. Not saying it doesn't happen, because it does happen, because I've seen pictures of it. But one thing, for an example, that's a little bit different, and this is where technicians maybe got a little bit complacent, but when you go to change, fix a leak on a coil, just say it's a 5-deck coil for an example, and you pump out that whole circuit so you know there's no more synthetic refrigerant in there. We'll say we're talking about synthetic. It's empty. You fix the weld, you pull a great evacuation, you pull it down real low so it's below 500 holding, you do whatever you have to do. And then what valve should you open? What valve should you open? Should you open the liquid line valve or the suction line valve? See it in the chat. Because this is important. There, Dave, exactly, David. You should open the suction, but I've seen many times, and you should open it slowly. But I've seen many times where even myself, to be honest with you, I'd open the liquid first because nobody taught me, nobody told me. I'd fix it, just open, let's get the liquid through. So in CO2 refrigeration, you need to make sure you open the suction line so you get that vapor inside that coil, right? Because if you have a vacuum and now you open that liquid line, you could potentially cause dry ice in that coil. So that's just one thing to think about. Open that suction ball valve real slow. And just always open it slow so you start to fill it up with that CO2 vapor. And that's a tip for you. But once again, that is something you need to do with synthetic refrigerator. And lots of people just will open up that liquid line right off the bat. Always make sure that you have at least, it's over the 61 psi, but most manufacturers say, well, you want 100 psi or 140 psi or 8 bar or 10 bar amount of vapor inside that system before you start charging liquid. Okay, so just be aware of that. Does there need to be liquid present or a certain density of vapor to create dry ice? So I tried to create a lot of dry ice. I've pulled cylinders like this big and a header, probably 4 inches by maybe a foot or 2 feet, and I pulled an evacuation, deep vacuum, and I blasted liquid into there. I couldn't cause dry ice. But I really believe it's because I was going through 1/4-inch lines. So I think it was flashing before we get in there. I've seen it too when I'm emptying systems and cause a plug in the line. But the only time that really happened is when I kind of slowed down the liquid coming out of that line. When that's full blast at 1200, 800 psi or whatever it is coming out. I can't remember what that is in bar. I should look at my. So 66 bar or whatever, 70 bar. It's just blasting out, and you're usually just shooting, and you'll start pucking a little bit. You got to do it safely. Safety glasses on, safety gloves. When you have to empty a system for a service. I've never caused dry ice, but when I slowed down that, so I'm on a ball valve and I slowed it down, I caused dry ice in that line. So you want to be careful and safe on that, just to understand that, because if you cause dry ice in that, say 1/4-inch line, if it's a 1/4-inch line, you better hold on to it and wait until it shoots out and point it at the ground away from, because it is going to shoot out. Because you got a lot of pressure behind it unless you have a ball valve. You should always have a ball valve behind it to safely shut it off if you're releasing gas of the system. But I've seen it before where it's shut out and a hose going around like this. So you want to be very safe about that, because you can create dry ice. But in that cylinder, I tried to create dry ice. I couldn't. I think it was because of the 1/4-inch lines. So I didn't answer your question, Adam, there. That's a good question I'm going to write down to ask some of the experts that we bring on. All right. Couple minutes left. Does anybody else have any questions? So next week, I'm going to have a guest on. Please have some questions. If you have any questions this week that you want me to bring up next week, some things that you want to learn about if you're new, or even if you have some experience that you want to learn about a certain topic, we're going to talk, like I said, we'll talk about parallel compression over the weeks, warm ambient controllers and systems, and we'll dive in a little bit deeper for both the new people and people that have some experience. But hopefully there was a little bit of value today. Like I said, over the weeks, I will have more guests on. If you know someone who's an expert in CO2 refrigeration, you think they would be good here to have a conversation for everyone, please let me know. I'll reach out to them. I don't mind asking to see if somebody's willing to come on and share their knowledge. Awesome. I don't see any more questions in the chat. I want you guys all to have a fantastic and safe week. And next week, let's get a conversation going. See you all later.